Okay, I'm going to use this video to show you how to draw some line diagrams. So we're going to start with some examples that are structural formulas, and then we'll take those to line diagrams. And then I'll do another video where I show you how to go from a condensed formula into a structural formula. And then you'll be able to do the whole picture. So let's start here. The first thing that I always say to do is to count your carbons. So I'm going to go 1, 2, 3, 4. And then I look and I say, okay, here's the substituent. Now, remember, this is not numbering to name the molecule. This is just numbering the carbons to make sure that we replicate exactly what's there in our line diagram. So if we were numbering to name it, we would have to go in the other direction, but we're not worried about that right now. Okay, so I'm going to draw a line diagram that has 4 carbons. 1, 2, 3, 4 carbons. And then coming off of carbon 3, I have a substituent that is a methyl group. And that's it. And so if you were turning this in, you would erase your numbers, and that would be your final. But I'm not going to erase my numbers from here on out. I'm just going to leave them just so that we can keep track. Okay, so the next one, we're going to number our carbons. 1, 2, 3. Oh, there are 2 things coming off of 3. 4, 5, 6. We got a methyl. 7. So I need to go 7 long. 1, 2, because remember, everywhere where it ends and where we have a joint, that's a carbon. So each of these places represents a carbon. And you would never put the dots on a drawing that you were turning in, but just to kind of keep an idea of where those carbons are. And then we don't draw the hydrogens. You draw every other atom, like an oxygen, a nitrogen, something like that, you would draw. But here, all we have is carbons and hydrogens. So carbons are at the ends of the lines, and then hydrogens are understood. Okay, 1, 2, 3, 4, 5, 6, 7. So coming off of carbon number 3, we have 2 things coming off of carbon number 3, 4, 5, 6, 7. And I'm going to show you more than one way to do this. So the correct way to do this is really to draw one methyl and then the other methyl coming off this way, because this is really in 3-dimensional space, how they get as far apart as possible. But it would also be technically correct if you said coming off of 3, there's a methyl there. Let me erase my number here, and that's a methyl. That's also a correct answer. So I would mark that as correct. I just wanted you to know that either one is good for B. That's all for B. Okay, so let's see, we did our 2 methyl groups on carbon 3, and then we got to go to carbon 6 and give carbon 6 1 methyl group. So either one of those structures would be correct. All right, C. Go 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons. Then coming off of 3, we have 2 methyl groups, coming off of 7, and coming off of 8. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And it doesn't matter. You could start going down by going down 1, 2, 3, 4, 5, 6, 7, 8, 9. You just see if it's an odd number. If you start it up, you're going to end up. If you start down, you're going to end down. But it doesn't really matter which way you do it. Makes no difference at all. Okay. So we have our 9. So coming off of 3, 1, 2, 3, we have 2 methyl groups. So I'm going to give 3 2 methyl groups. 4, 5, 6. Now coming off of 7, we have a methyl group. Coming off of 8, we have a methyl group, and 9. And that's all you have to do. And then just don't forget to erase your numbers. No big deal. All right. So now we're going to turn these also into line diagrams. So do the same thing. Count 1, 2, 3, 4, 5. And remember, this is not the right numbering. This is just for us to get an idea of how many carbons are there. So we go 1, 2, 3, 4, 5, and we got 1. Then coming off of 2 is a methyl group, 3, 4, 5. So that's what I kind of do is I read across, I count them, I draw my base, and then I come back and I go, okay, carbon number 1, that had nothing. So I just put the number, and so on and so on. Now, here we have 1, 2, 3, and coming off of carbon 3, we have 2 methyl groups. So I'll show you a couple of different ways to do this. So here's my base where I have 1, 2, 3. So coming off of carbon 2, I have 2 methyl groups. So the way that you would draw this is coming off of carbon 2, there's 1 methyl group, there's another methyl group. It ends up kind of looking like an X. So that's the standard way to draw it. But if you drew, so 1, this is 2, this is 3, if you drew it coming up and going down, that's also acceptable. So either way is acceptable. Okay, 1, 2, 3. We have 2 methyl groups off of 3, 4, 5, 6, 7, 8. We got a methyl group, 9, 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So nothing until we get to carbon number 3. Carbon number 3 has 2 methyls. Then 4, 5, 6, 7. When we get to 8, we got a methyl group, 9 and 10. And then just go and erase your numbers. I got to keep saying that. So I'll do that. All right, 1, 2, 3. Ooh, coming off of 3, we got some stuff going on. 4, 5, 6. Okay, so 1, 2, 3, 4, 5, 6. And what you'll see is when you do this, sometimes it really is easier to turn it into a line diagram than name it. You know, it just, sometimes it's just easier that way. And I think I gave 1 too many numbers here. 1, 2, 3, 4, 5. Yeah, okay. There we go. Okay, so we got 1, 2. When we get to carbon number 3, what we have is a 4 carbon group. Now, coming off of the parent, we're going to give it this carbon right there, is that carbon right there. And now that carbon is attached to 4 different things. And so it kind of ends up looking like an X or a plus sign, however you want to kind of think about that, just because they're trying to get as far away from each other in space as possible. And so the carbon coming down, you could do this, this, this. As long as you have 4 there, the angle really doesn't matter. So that's carbon number 3, 4, and 5. So then B down here, we go 1, 2, 3, 1, 2, 3. And then what we see is between carbon 2 and 3, we have a double bond. So you just put another line and that indicates a double bond. So the only difference between B and C is that B has a double bond, whereas C does not. It's the only difference. Still 1, 2, 3. Okay, same thing. We're going to do a few more. This, I think the last set. Yep. Okay, so let's count 1, 2. Whoa, coming off of 2, we got a methyl and a methyl. 3, that's a double bond. 4, so between 3 and 4, we have a double bond. 5, 6, we have a methyl. 7, we have a methyl. 8, and between 7 and 8, we have a double bond. So if you want to highlight it, you want to like remember it somehow, we don't forget to put in those double bonds. Okay, so we first need our base, which is 8 long. So it's 2, 3, 4, 5, 6, 7, 8. I'm going to go, as I go across, I'm going to go 1, 2. Okay, 2 gets 2 methyl groups. 3, and when I go to 4, I have a double bond between 3 and 4. And it doesn't matter if you put the double bond, like, okay, if this is the the thing. You could put the double bond on the bottom, or you could put the double bond on top like that. And if you had a triple bond, you would have the 3. Okay. So where do we stop at? 4, 5, doesn't have anything. Now 6 has a methyl group. 7 has a methyl group. And then between 7 and 8 is a double bond. And then just don't forget to go back and remove those numbers. And that's your final drawing. Okay. 1, oh, we got a double bond there. Let's do a little bit of a lighter color. Double bond there. Sometimes if you just want to go in and highlight them, you know, and there's your methyl group and a methyl group and a methyl group. So we have a double bond between 1 and 2. On 3, we have 2 methyl groups. Between 4 and 5, we have a double bond. Between 6 and 7 is a double bond. 8 has a methyl group. 9 and 10, there's a double bond. Okay, so 10, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so we said between 1 and 2, we have a double bond. Then on 3, we have 2 methyl groups. 4, between 4 and 5, we have a double bond. Then between 6 and 7, we have a double bond. Then on 8, we have a methyl. Then between 9 and 10, we have a double bond. So just like read across, and you're going to typically get it pretty well. All right, last one. 1, 2, 3, 4, 5. Now what do we have here? We have a double bond between 1 and 2, a double bond between 4 and 5, and a methyl on 3. So we're going to go 1, 2, 3, 4, 5. 1 between 1 and 2 is the double bond. On 3, we have a methyl. Between 4 and 5, we have a double bond. And that's it. All right, hope that helps.